Welcome to section 7.8, Variation. We begin by defining two types of variation. We say that a variable y varies directly with the variable x exactly when, for some real number k, we can write the relation y is equal to k times x. We say that a variable y varies inversely with the variable x exactly when, for some real number k, we can write the relationship y is equal to k over x. In both cases, the number k is called the constant of proportionality. Some real-world examples we might find of directly proportional would be the number of cans of paint that you need and the size of the wall that you wish to paint. Those two variables are directly proportional. Two variables which are inversely proportional would be the amount of heat you feel from a fire and the distance you are from that fire. The further you are away, the less heat you feel. Now we begin with example problem 1. If x varies directly as y, and if you know that x is 7 when y is 6, then find x when y is 24. Since y varies directly as x, we know that there is a constant k such that x is equal to k times y. We then use the information that we're given, x is 7 when y is 6, to figure out the value for k. Substituting in, we see that x becomes 7, y becomes 6, and we solve for k. Dividing both sides by 6 gives us k is equal to 7/6. This gives us the equation x is equal to 7/6 y. Now, when y is 24, we have 7/6 times 24 gives us x. This means that x is 28. For example 2, we know that the volume of a gas in a container at constant temperature varies inversely as the pressure. If the volume is 23 cubic centimeters at pressure of 9 pascals, find the pressure when the volume is at 58 cubic centimeters. Since the pressure and the volume are inversely proportional, we know that for some constant k, that P is equal to k over V. When the volume is 23, the pressure is 9. Substituting these values into our equation, we are able to solve for the constant k. K becomes 23 times 9, or 207. This gives us the relation P is equal to 207 over V. Continuing with the example, this gives us the relation P is equal to 207 over V. When the volume is 58, we want to know what P is. Substituting into the equation, we have 207 divided by 58 gives us 3.57 pascals. That is rounded to 2 decimal places. For our third example, suppose that a weight of an object varies inversely as the square of the distance d from the center of the Earth. At sea level, 3,978 miles from the center of the Earth, an astronaut weighs 125 pounds. We wish to find her weight when she is 115 miles above the surface of the Earth and the spacecraft is not in motion. Since the weight varies inversely as the square of the distance, we have the relation W is equal to K over D squared. Using the fact that she weighs 125 pounds at a distance of 3,978 miles lets us find the constant K. Substituting into the equation, we have K is equal to 125 times 3,978 squared, giving us 197,806,0500. This gives us the equation which you see here. When at a distance of 115 miles above the Earth's surface, we have the distance from the center being 115 plus 3,978, or a distance of 4,093 miles from the center of the Earth. Substituting this into our relationship for D, we have W is equal to 197,806,0500 divided by 4,093 squared. This gives us an approximate answer of 118.07 pounds.